Hey folks, Quill18 here, back with the continuation of our tile map tutorial, and hey, it didn't take 4 months this time for the next part. So, being off air also for 2 seconds enabled me to realize exactly what the problem was with our tiles map being inverted. So what we have to do is, first of all, I have to remember that the UVs were an index of the entire image, and it ranges from 0 to 1. Well, actually, it ranges from 0 down here to 1 up here normally, based on the way we were counting. So all I did is I just threw in a 1 minus what was in there before to flip it. So anything that was a 0 before is now a 1, anything that was a 1 before is now a 0, and then in between gets inverted. So everything gets mirrored that way, and everything is hunky-dory. So all I need is that one little fix. So moving on, we're talking about how to connect all these rooms up together. So what we want to do is, well, there's a couple of things, and it's not going to be so bad, really. We want to, first of all, let's create code that will just connect, make a corridor between 2 rooms. All right, that'll be the start to do that. So I'm going to create a function. This is in our tile map, and it's going to be called build corridor or hallway or whatever, and it's going to go from room 1 to room 2. We want a corridor from this room to that room. And how are we going to do it? Well, first of all, I think what would be nice is if we could know exactly what the center of any given room was. So let's go ahead and get a function here that returns, I suppose, a vector 2 that is the center. Or you know what we'll do? We'll do another kind of accessor function like this. Public int center x coordinate, so the center in the x. So we'll get return. So what is it? It's left plus width divided by 2. That's basically our center in the x direction, and then in the y direction it's going to be top plus height, right? Because when we're building these corridors, I'm going to build it from the middle of the one room to the middle of another. And again, you know, you might not want to do this. You might want to pick a random place inside the room to build the corridor. That way you might get slightly more interesting generation, but this is going to work okay for us. So we want to just do one of those sort of staircasey kind of things, right? Where, my brilliant drawings, room here, and what we want to do is we want to like just carve out, there's a corridor tile. We just want to flip these tiles to floor, and then a bunch more to floor this way, like this, and then, you know, one that way, and there we go. That will be our corridor, and we can do that. That's fine, no problem. So build corridor. Okay, so we are going to have the starting position, or current position maybe. We'll go, well, x is equal to room1.centerx. We're going to start here. Int y is room1.center y. So for, well, I guess we could have done that. It's just for x. We're not really doing anything there, which means we can actually skip this first thing. Maybe we'll use a while for a change. Oh, there's something I never do. While the x is less than room2.centerx. We're going to do some sort of loop, and make sure to do the incrementer, because I'm really bad for forgetting to do that, which is why I don't usually use while loops. I like for loops because I don't forget to increment things. And the same thing, while the y is less than r2.centerY. All we're going to do is in our map data, at x, comma, y, we're going to set it to the floor, which is a 1. And probably that works. Let's find out. It's not, yeah, it'll work-ish. Okay, so we at this point we know what rooms are okay. Here we're sort of actually making the rooms for real, which is fine. And then what we're going to do is I'm just going to say make corridor. Of course I use make and then build because, you know, consistency, that's what's important. Make corridor. Then we're going to make a corridor, and I'm simply going to use, for now, rooms from room number 1 to, well, room 0 to room 1. The first 2 rooms are going to have a corridor that connect them, And let's see what that does. We'll see if we crash Unity or not. Generate. Excellent, nothing's happening. I'm sitting here scratching my head, but you probably can't hear. Oh, first of all, whoa! I have no idea why we didn't end up with an infinite loop. Oh, I can see one of the problems. Oops. I can definitely see one of the issues. Huge problems. But if we keep doing this long enough, we should at some point get a case that works. Or did I hit regenerate before it... yeah, okay. So we still have an infinite loop. And the reason is... And now I'm going to have to crash Unity. Excellent. The reason is because I am naively just choosing the first room and going in the same direction, which is wrong. Oh, the recording is probably effed as well. Where's Unity? End process. Boom. Wouldn't surprise me if that has desynchronized the audio. I hope it didn't. Why am I still at 100%? Okay, we're fine now. No problem. No problem. Everything is fine. We're all fine here. How are you? Good. Okay. So, yeah. So, what is going on? The problem is, I naively assumed... Thank you for messing my code here. I naively assumed that room number 1 in this case would have the leftmost x, or the smallest x and the smallest y in my test, which is not true. Which is absolutely not true. So this code only works if room 1 is to the left and above room number 2. No good whatsoever. So let's rewrite this code to take that into account. Alright, so we can still do this. We're going to loop as long as the x is not equal to the other x. And y is not equal to the other y. And we're still going to do this. It's just this increment is actually not going to do. We're going to say y is going to be equal to y. Well, we can do a plus equal here. It's fine. But we want to either a positive 1 or a negative 1. And it's just going to come down to whether or not the y that we currently have, if the y that we currently have is smaller than R2's y, then we're going to use the trinary operator. Then we can add 1. Otherwise, we want to remove 1. And we know they weren't equal because we've tested for that right here. And then we're going to do the same thing here, except it's going to be the x, center x, same thing. Now, we should hopefully have code that doesn't instantly crash and also just generally kind of works better. That's a big should. Regenerate. Okay, we got something being created here. Clearly still not getting the job done. But it's at least not crashing us. Every time I hit save, because I see the little star that my scene's not saved, and I just intentionally... So that one's technically, I think it's connecting these two rooms and doing that kind of right. Alright, let's reanalyze the code here and figure out what we have done wrong. Well, let's simplify the case. Let's only make 2 rooms. And hope to God they don't intersect. You could also wrap this in a while. Like, there's a couple of different ways to do it. If you want to guarantee a certain number of rooms, we could do something like while number of rooms is less than 10. Keep trying this, but you probably want to do sort of maximum of tries, like max number of like fails, at which point you just bail out of this. How would I do that? For example, so while rooms dot count is less than 10, no, less than 2. So I just want 2 rooms here, and int max fails equals 3. So if the room collides, then we're going to take away from one of the potential max fails, and then if max fails is less than or equal to 0, then we're going to break out of this while and just give up. So now we should end up with 2 rooms. There we go. I hate when I hit the regenerate button before it's actually recompiled. Alright, I think I probably have a very simple logic error in my code down here. Well, first of all, it will bail here probably too early. This is not what we want. We want it to loop as long as either one is not the same. That makes sense. So while the X doesn't match or the Y doesn't match, we're going to keep looping. And then what we'll do is we'll find out which direction we want to move in, based on the difference between the two. If X minus R2 center X is larger than the difference between Y and R2 dot center Y, then we want to move XYs. Else, move YYs. And actually, let me copy this, undo, 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 many more undos, because I actually want those lines back so I don't have to rewrite them. There we are. And moving XYs means this, and moving YYs means that. And in any case, we want to set the map data to be equal to 1 in this particular spot. There. So if the difference in X's is larger than the difference in Y's, then we move in X, otherwise we move in Y. And then we stop whenever the X is equal to the Y. Alright, let's give that a try and see if we've crashed anything. 2, 3, wait for it to regenerate. Boom! Hey! Now there we go. Now, this diagonal kind of line may not actually be what you want to do. Depending on the game, you might want to have it go in one direction first and then the other direction. And that is entirely possible. And it just means a slightly different loop here, where you actually kind of want a pair of loops. Right? We could do that. That's pretty easy. Let's go ahead and do this. Let me copy this loop twice, or make a second copy. And just back this up. This only does... We're going to move in X until the X's match, and then we're going to move in Y until the Y's match. And again, it really depends on what kind of map you're trying to do. I like straight corridors, so this makes straight corridors. In fact, you might want to keep multiple functions. Make straight corridor, make diagonal corridors, and then, depending on what level you're on, generate completely different kinds of corridors. Come on, there we go. That's what I'm talking about. Now, this may or may not be what we want. Because what it's doing, it's starting from the middle, going directly to the X and then to the Y. And also, we're always moving in the X first. We might want to flip it around so that it moves in the Y first. I'm not sure that visually that would ever do that much that you would notice one way or another. But those, these are all different options. So that's not too bad. And then if we go and come back here, and we're going to try to create up to 10 rooms, but we're only going to allow 3 fails. So now, come on, regenerate. There we go. So we get very different numbers of rooms. Wow, but the fails are really... Here, we can fail up to 10 times. We just want to stop infinite loops from, like, if you get fail, 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 fail. There we go. That should end up... Now we should end up with much more populated levels. Not bad. Okay. Probably want bigger rooms, to be honest. Much larger rooms. And frankly, let's go with a bigger map size as well. Let's go with something maybe that's twice as wide in the X. And our rooms, we'll do something similar. We'll get the X's can be a little bit wider than in the Y, just because I feel like it. And then I'm actually not using the game view, so we can do something like that. Regenerate. There. I like it. Okay, so we're still only combining the first 2 rooms. And so now what we want to do is, we want to make sure that all rooms are connected somehow. And so what we can do in our room data over here, we can put in a bool, which is connected, which defaults to false. When we create a new room, it is not connected to anything. And here's what we can do for every, well, there's a bunch of different ways I can do it. But what I want to do is I want to loop through every room that's not connected, and then connect it to another room. And then we can just repeat. It's a pretty simple way of doing it, but it's a way that works. So this corridor, after it's done building the corridor, as a final step, it's going to set is connected. Why is it not auto-completing for me? I hate when it does that. I think it may just need a render or something. Is connected. Oh, no, that should work. It's true. And it says, oh, it's not public. That's why. We want is connected to be a public boolean. All right, so we can tell whether a room is connected to the rest of the map or not. And so here's what we want. We've drawn the rooms at this point. So let's do bool all connected. This is going to be a pretty naive way of doing it, but it's going to work. Bool all connected. While all connected equals false, or I could have done a not. We're going to keep looping until we hit everyone being connected. So how are we going to find out if we are? Well, what I should really do at the top of this function is just have my droom r. That way I don't have to instantiate it here. And here I can just use r and r and r. So we can set all connected to be true. We're going to assume that all rooms are connected at this point. Why are you whining at me? Is it really? But then it's going to complain that it's the same thing. Is that really how for eaches work? Oh, that's really annoying then. There's got to be another way. I'm just not using it right, but that's all right. Okay, let's ignore random syntax bullcrap and get back to the logic. R2. Okay. For each room, D room R3 in rooms. If R3 dot is connected, if it's not connected, right? If it's not connected, then first of all, we know for a fact that all connected is equal to false. Actually, we don't need to loop like this. It really depends on what kind of damn room structure I want to make. Let me rewrite this function. Because I've done a few different types of maps, and again, it really depends on what you want to do. Because what I've done before is I've done a pass through R3, and for every room in the array to start off with is just literally connected to another room at random in the maze. And then I did another loop afterwards to say if it was connected or not, then do something about that. But you know what, this is fine. Loop through your room. If it's not connected, then we are going to make a corridor from room R3 to another room. And it's going to be a random range. Well, we don't want it to be the same room as we are. Okay, so if it's not connected, we want to make a connection between this room and another room with some sort of to room I is what we want to do. So how do we determine what I is? Well, we can do random.range 0 to rooms.count, right? That seems like it would work. The problem is this might end up picking our own room, which we don't want. So, I mean, we could iterate until it's not, but I think we can come up with a slightly more elegant way of doing it. Random range, so this will return, so if we've got 10 rooms, this looks like 0, 10, but it will return a random number from 0 through 9. We'd actually take it down by 1. So if we've got 10 rooms, this will return a random number that is either 0 through 8. All right, which is 1 shy. And then what we can do, we need to know our current room ID. So I was going to say, oh, it'll be easy. We'll do a modulus and this and that, but we actually don't, because the way we're doing it, we're not keeping count of where we are. All right, so fine. Instead of a for each, we'll do a for and I equals 0. Just change this to j because it's going to be very confusing otherwise. I is less than rooms.count, I plus plus. It's very similar to the for each. Technically, for each uses more memory than a for loop. I just like for each because I think they're elegant. So rooms I. So if rooms I is not connected, then we're going to find another room with ID j. And j can be 0 through 1 less than the actual number of rooms. So again, if we have 10 rooms, which means rooms 0 through 9, j is going to be something 0 through 8. So we're going to go make a corridor from rooms I, which is our current room, to rooms I plus j. But then we've got to take this, because this is very likely to go above our limit, and actually do a modulus rooms count. What the hell does this all mean? So let's say we are room 5. We are room 5. And then j ends up being randomly picked to be room 6. And there's 10 rooms in total. Well, 5 plus 6 is obviously equal to 11. But 11 modulus 10, which is the number of rooms we have, will loop around to be 1, which is what we want. So if it ends up being, if we ended up with a random number of 5, 5 plus 5, 10, so this would actually be looping us back to the beginning. And the beauty of this is that the maximum that j can be in this case is an 8, right? So 5 plus 8 is equal to 13, and 13 modulus 10 will give us a remainder of 3. Wait, am I doing this wrong? I am doing this wrong. It's not minus 1 that we want to do here. It's a 1, because we don't want j to be 0, because that would be bad, because if it's 5 plus 0 is equal to 5, which means ourselves. So 1 is going to be fine, because that leads to 6. And now the maximum that j can be, if we've got 10 rooms, would be 9. 5 plus 9 is equal to 14. 14 modulus 10 is equal to 4, which is just before us. So now we've done this, which guarantees that we cannot pick ourselves. We might pick a room that already has a corridor in it, but that's okay. Nothing wrong with that. So now we're going to loop through each room. And the thing is, if we get to a room that has already been connected, so first room is 0, that's obviously not connected, so it's going to pick another room. Let's say it picks room number 3 to connect a hallway. And when we get to room number 3, it's already going to be connected, so we're not going to build another corridor. We could do a random chance if it's not connected, or if it's connected, but there's still a 1 in 4 chance that we're going to decide to build another corridor in there if we want. A room, even in this setup, could end up with multiple corridors because, again, in our first room, ID 0, we'll automatically build a corridor. But then the next 3 rooms, which are not connected, might randomly decide to build a connection to room 1. Also, this code here can pass a corridor through other rooms. So it's actually going to end up with a fair amount of interconnection using this relatively naive way of building it. And again, these are the sort of roguelike maps. These are very different from the sort of structure that you end up for Diablo-like maps. We'll talk about that very briefly. We won't actually make an example of it, but we'll discuss the logic. And there you go. You can see that the rooms are all getting kind of connected. I'm not keen on the fact that they do sort of chop off these walls. But it does lead to one interesting question here of, obviously, we want the corridors to have walls and not be stone. Probably. So how do we deal with that? Well, There's a couple of different ways. Here, I could do something when I'm making the corridor is check all adjacent tiles at this point to see if it's stone or not or whatever. Actually, it's not a bad idea to do it there. So what I was going to say is we can make a pass afterwards. Make a pass in every tile here and find any tile, any stone tile that is adjacent to a floor and turn that tile into a wall. And that would work fine, right? Literally loop through every tile on the map. If I'm a stone tile, but one of the tiles adjacent to me is a floor, turn me into a wall. It's not quite as efficient as doing it here, where we set the tile to be wall. Well, here maybe we should also at the same time, or sorry, this sets the tile to be floor. At this point here, we might want to check anything adjacent to us that is stone, make it into a wall. Either one will work. Technically, this means checking a few less things, I think, but it's slightly more complicated. So we're going to skip it. We're gonna do the thing where we pass through the entire thing. We're going to wallify the map, and that's what I'm going to call it. I'm going to call it make walls, and this is just going to go through the entire map and make walls where appropriate. Int x is equal to 0. X is less than size x, x plus plus, and the same thing but with y's. And what we can do is something like if has adjacent floor. If the tile at xy has adjacent floors, then set map data of x comma y to be equal to 2, which is our wall, right? 2 is our wall. And also, technically, we only want to do this test if we are stone, which means our type is equal to 3. So if we're equal to 3 and we have an adjacent floor. So let's, simple. Bool has adjacent floor int x, int y. Do we need to check diagonals? I suppose we do, which is a little annoying. So there's a few different elegant ways of doing this. I'm just going to do a whole lot of if statements. But what we also have to do is make sure that we're not, that it's valid, that we're not off the edge of the map. Because we don't want to do, because normally, here's how we do it. If map data, and we're going to check the tile to the left of us to start off with, right? So the tile to the left of us is x minus 1, y, is equal to floor, which is 1. Then we could return true right away. Right? We know for a fact that there's some adjacent floor. And then we'll do a bunch of other tests, and if none of them come true, then false. There's no floor adjacent to us whatsoever. The problem is that this might be, if we are the leftmost tile, this will be off the map. So we also need to check if x is larger than 0 and that is equal to 1. Then we know the tile to the left of us is floor. Also, if x is less than size x minus 1, and plus 1 is equal to that, return true. So this is to the left and to the right of us, and we can do top and bottom, which is all the same except with a bunch of y's. Y, and then the x is the same, and this is a minus 1. The x is the same, and then a plus 1. Those are true. And then diagonals are slightly more annoying. Although we can sort of group them in like this. Let me think here. I guess not. Oops. Undo. Copy. So we're going to check the top left tile, which is only true if x is bigger than 0 and y is bigger than 0 and that is the tile to the up and left of where we are. And then we will check the up and right, which is size x minus 1. The up and right is a plus here. And then we'll check down and to the left and down and to the right, which basically is a duplicate of this stuff here. which is only good if y is not too large. And down would be plus in y, and plus here. Okay, I think that will make walls correctly without crashing. Again, doing this on the fly, very tricky to get all the pluses in the right direction. Regenerate, there we go. So now our corridors are walled off as well. And we've got a map. And then there's lots of ways to tweak how we produce this map to get it to work exactly the way we want for our particular look. But that's such a case-by-case basis thing. But now, you know, we have a simple but functional map for a true classic roguelike dungeon experience. And hell, flip it on its side, and now you've got something that might work in a Metroidvania kind of game, you know? You'd think of this vertically instead. As long as, you know, you can wall jump up these kind of areas here, you're going to be okay. This is the sort of thing that goes on maybe in a Splunky game, for example, right? Although, obviously, then you keep iterating and adding more and more characteristics. The other thing you can do, these are just empty rooms right now, but what a lot of more advanced roguelikes, but still very classic roguelikes will do, will be like, okay, I've just generated a room that has this much space in it. Well, I can just set a bunch of floors and then drop a random item in here. It's like, oh, we'll put a random table in one spot and some gold on the floor over here, right? You can start filling the rooms with various objects like that. Some of them will be different tiles. Like a table might be a different tile than a floor tile, or it might represent an object that sits above the floor, for example, like a pile of gold coins. But the other thing you can do is have a library of predefined room configurations that fit this layout. You know, so there's a 1 in 10 chance that a room of this size, instead of just being this kind of room right here, we're actually going to pull the chapel room out of our little library, which is automatically going to put an altar right over here and then a bunch of pews and some crosses or something in the corners or something of that effect. You can have these kind of little lookups, or you can flip it around where you before you generate the random rooms, what you do is on every level we're going to include between 0 and 2 of these special rooms. So first we're going to put down a chapel over here, and then we're going to put down a library over here, and then we'll put in a few random sort of generic rooms, and then we're going to connect everything up via corridors, right? That is a perfectly fine and logical way to do things. Also, these corridors, when you're running around here, you could have them stop when you hit structures. I mean, there's, again, so many different ways, but this is a very classic, very old school roguelike kind of map, and it would work. I mean, then it becomes a question of like how to implement the rest of the logic and the movement and different things. And again, for this sort of thing with this sort of tile map structure, you really want to get away from your normal kind of Unity-ish thinking in terms of how you handle motion. Instead of, you know, checking colliders or whatever, in a true roguelike, you're just using the tile map data. Your player character knows his coordinates, and so if the player hits the left arrow on the keyboard, what you do is you say, listen, the tile to the left of me, so the tile at x minus 1, is it a floor tile? Yes? Okay, now I'm going to put my character there instead, and so on and so forth. Or you actually end up with slightly more sophisticated stuff where you keep developing well, there's a couple of different ways of doing it, but instead of checking the floor tile, you know that tiles of type 1 are walkable. Tiles of type 15, which represent water, are only walkable if your character can swim or fly. You know, so you start putting those things in there. And then the other way is the more sophisticated stuff where instead of a tile being represented as a simple integer, you come up with a tile class. And you know, not unlike what we did with the room here, but probably in its own file. And the tile is just, the tile class becomes something like protected class D tile. Whoops. And then you set, you know, booleans. Is walkable equals false. Bool is lava. You know, it does damage to you. It does fire damage. And you can have those sorts of things. And then you can have some sort of library where, okay, so you've got these details, is walkable, is not. And then, oh, yeah. And you would want an integer, which is tile graphic ID, right? Which would default to 0 or something of that nature. And then what you do is you define, okay, so I've got a D tile, and this is my tile floor. and then tile floor, I mean, I'm doing this in the wrong place, but is walkable equals true, and tile floor dot tile graphic ID is equal to 1, right? And so you have some function, init tiles, like this. You know, you could have this outside like that. So then later, when you're setting up the tiles and you're building your room, so where's our make room? Our make room in, right here, instead of setting a number, what you're doing is you're setting a tile floor. But obviously your map data wouldn't be an array of integers, it would be an array of dtiles. And you could totally do that. And instead of using something like dtile tile floor, you'd actually probably do something like list dtile tile types. And then you do something like tile type 1, like this. Hell, you might do something like a string name equals unknown as a default. And then down here, tile type 1 dot name equals floor. So then when people mouse over the tile, you can tell them what the floor type is. You can tell them other information. You know, the is lava thing becomes more like damage per turn. Well, on a floor is 0, but if it's a lava tile, then you set damage per turn is equal to 10. Every turn you spend on lava, you take 10 points of damage, for example. And that, you know, this is what you sort of develop entirely based on what kind of game you're making. And so the other thing too is in your tile map, right now we do have a, what is it? We have get tile at, we call. Yeah, here, get tile at. Well, what we actually want here is we don't want the tile. We don't want dtile to be returned to us. We want get tile graphic ID at. Because what we want to do then is for get tile at, here, get tile graphic ID at dot tile graphic ID and so on. So these are just, it depends on exactly how you're planning on using it. Let me undo that change here just to get it so that it's working again. I'll get rid of that. I will simply comment this out and leave that in there so that when I upload the code, you guys can still glance at that sort of craziness and get an idea of what's going on. Did I leave anything else broken? Clear? Clear? Come on. You can do it. Regenerate? Yeah, okay, good. So, again, depends very, 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 very much on what you're trying to do. Now, most more recent and modern action RPGs, these are sort of the modern day variant of the classic roguelike. You have things like Diablo, Path of Exile, all this. Within the dungeon areas, you can sort of use this, but they do tend to use a different technique. I will make another video where I discuss the technique that they might employ, but we actually won't go and do a code sample for that. So I will go and do that right now, I promise, not 4 months from now. See you next time, folks. Bye.